our editor needs to know the global tile X and tile Y, as well as the size of that tile denoted by a tile size exponent, TE7. We have a set of constants here for the tile max index and address index, X or Y, for the different tile sizes. So when we're using the smallest tile size, we have a 960 by 960 grid. Max address is going to be -1. For the largest tile size within the DOM, we have a 15 by 15 grid of tiles. That's the size of an entire level. And we need to -1 to get the max address. Here we have the size of a level measured in different size tiles. For the smallest tile size exponent, for the smallest tile, we have a 64 by 64 grid. Every time we go up a different power of 2, we half the number of tiles, 64, 32, 16, all the way down to 1, a gigantic tile that's the size of an entire level. Here we are checking our math. Here we are creating those, actually these are the addresses of those 3 variables, the addresses on the shader. Here is a lookup table for exponent to the tile max index, lookup table for tile size exponent to the lateral span of the level, monkey wrench macros, where we are setting the new values into the GPU with the uniform put function, where we are getting the address of these variables within the shader. They have the same name in the shader as they do on the CPU side, so this is in render pipeline load right here. What we did previously, footnotes, and what we did in this video. This has been video 150.